Hello. We're going to be looking at problem 2. What we're going to do is we're going to consider preferences represented by the utility function 3x squared y cubed. Now, this is known as a Cobb-Douglas utility function. It's going to have a nice interior solution, and we're going to kind of just go through a lot of different exercises with this utility function. So first, for part A, we're going to find the MRS between x and y and determine whether it's decreasing in x, and then draw the indifference curves. So what we do is we just look at the MRS, not the MRX, the MRS between x and y. And we know that this is equal to the marginal utility of x over the marginal utility of y. So this will be equal to the partial derivative of u with respect to x divided by the partial derivative of u with respect to y. So this is equal to 6x times y to the third power divided by 9x squared y to the second power. Now if we rewrite this, this is just going to be 2/3 y over x. I got that just because 3 over 2 on the y's just becomes a positive 1 in the numerator, and the x to the first power over x to the second power is just an x in the denominator. Okay, so now what we want to do is we want to determine if this is decreasing in x. Well, we see that since x is in the denominator, as x increases, this whole fraction decreases. Formally, we note that the derivative of the MRS with respect to x is just equal to negative 2/3 y over x squared, which is less than 0, so it is decreasing. All right, now we want to draw the indifference curves for this utility function. So the indifference curves are basically going to look like kind of like nice concave downward sloping curves. They'll be like this. So, I'm kind of taking artistic liberties here, but they're just kind of curvy, downward sloping, nothing too fancy. So they're not straight. The slope of them changes as I change the amount of x and y I have. All right, so now for part B, we want to look at the case where the prices of the two goods are px is equal to 3 and py is equal to 2, and income is 10. Then we want to draw the budget line and find the optimal choice. Okay, so first the budget line. So for part B, budget line. We know that the price of x is equal to 3, price of y is equal to 2, and n is equal to 10. So the budget line is going to be 3 times x plus 2 times y is equal to 10. To plot this, what we can do is we can solve for y in terms of x. So I get 2y is equal to 10 minus 3x. Here I'm solving for y. So y is equal to 5 minus 3/2 x. So if I want to plot this, so this is my equation for the budget line. It'll be 5 minus 3 over 2 times x. So again, kind of a rough drawing, but the point is they're going to be downward sloping lines with a slope greater than -1. All right, So I believe we are asked to solve for the optimal choice of x and y given these prices and income. So optimal choice. Because the MRS is decreasing, we want to look for an interior solution. So at an interior solution, we must have the tangency condition. That is, we must have that the MRS between x and y is equal to px over py. So this means, in the context of our problem, we need for the MRS, which is 2/3 times y over x, we need for that to be equal to px over py. So we need 2/3 px over py is equal to, 2/3 y over x is equal to px over py. All right, so this is the tangency condition. Okay, so what we want to do is we want to solve for example, y in terms of x. Okay, so we get that y over x is equal to 3/2 px over py. And if I multiply the x over, I get that y is equal to 3/2 px over py times x. So I know that at the optimal point, I must have that y is equal to 3/2 times the px over py times x. So I plug this into the budget constraint. So what I do, into the budget line, same thing. I have px times x plus py times, what I do is I plug in the optimal value of y, and I have this equal to m. So what I want to do is I want to solve this for x and find the optimal demand of x. So I can cancel these two py's right here, and I just rearrange this to solve for x. So I get px times x plus 3/2 px times x is equal to m. In other words, I have that 5, I'll write another step, x times px plus 3/2 px is equal to m. In other words, x times 5/2 px is equal to m. So this means that x is equal to m over 2m over 5 px. This is the optimal amount of x for me to buy. Sorry, I will move this one down. Okay, so this is the optimal amount of x. Now we just use our formula for the optimal amount of y, and then we substitute in x. So we get y is equal to 3/2 px over py times the optimal x, which is 2m over 5 px. So the px's divide away, also the 2's divide away, and we get 3m over 5 py. So the optimal amount of xy is given by 2m over 5 px and 3m over 5 py. Okay, now what we want to do is we want to plug in m is equal to 10, px is equal to, what was it again? Px is 3, Py is 2. Px is 3, Py is equal to 2. So this means that x star y star is equal to 20 over 15, and then so 30 over 10. So in other words, 4/3, 3. All right.